In the second paper of the quantized space fluid series, an equation for the vacuum density is proposed as shown below, where the electrostatic and gravitational coupling constants for the electron are given by the following expressions. The vacuum density can be expressed in terms of today's Hubble constant, h0, and today's matter content fraction, omega m0, as shown below. If the age of the universe is fixed at 13.78 billion years, then to be consistent with the vacuum density of the study, the Standard Model gives. These results for h0 and omega m0 are compared to measured values for these two quantities in the two figures given below. In the first figure, the CMV data from the WAMP, blue circles, Planck, purple triangles, and Atacama studies, green squares, are shown together with results from two baryon acoustic oscillation studies, brown symbols. The red triangle in this figure represents the predicted results from this study. Today's observable universe radius is 46.09 billion light-years. The next figure shows the results from the Dark Energy Spectroscopic Instrument study. The results of the present study are shown by the red circle in this figure. The results of CMV studies are shown by the purple ellipse. The DESI results were calibrated using two different methods shown by the green and yellow ellipses. The areas enclosed by the ellipses represent two standard deviations. A dimensionless space fluid constant is proposed in this study, and it is denoted by psi. The space fluid constant is defined as the density of the Planck space fluid divided by the density of the vacuum fluid. It follows from the vacuum density model equation from the study that the space fluid constant can be expressed as other equalities for psi that relate its value to the cosmological constant, lambda, the electron radius, the maximum observable universe radius, the space fluid Hubble constants, and the maximum observable entropy are given below. Note that while the space fluid constant is defined in terms of space fluid densities, it can be calculated using the mass and charge of the Planck fluid quantum and the electron. In addition, it is also a simple function of the fundamental lengths given by the Planck length and the electron radius. The definition of the cosmological constant given by, together with the equations for the vacuum density and the space fluid constant from the study, allows expression of the cosmological constant as